All right, so section 3.3, we're going to talk about behaviors, graphs, how to kind of describe them so that everyone who's looking at graphs is using the same terminology. So it's a little bit vocabulary, it's a little bit algebra, but the basic goal here is we want everyone to be using the same words, the same descriptions, the same descriptors when we're describing graphs so that no matter who's looking at it, we all have the same idea of what we are looking at. So we look at average rate of change, which is essentially a make-believe slope that we can put onto non-linear graphs to kind of get an idea of what happened over a given period of time. Overall change. Okay, it's not slope. Doesn't mean the same thing as slope. It's just kind of like, say I'm looking at the price of something over 4 years. Well, that price may have gone up and down and up and down, but at the end of the 4 years, it was maybe $5 more than it was 4 years before, or something like that. Okay, so the idea is, in general, what has happened to this graph. Then we can look at whether the graph is maximum or minimum points, what those are, where they are, how they affect what we're doing. And then we can also talk about whether graphs are increasing or decreasing. Are they getting bigger over time? Are they getting smaller over time? Are there places where it's doing both things? Is it, increasing in some places, decreasing in others? Those kinds of things where we can just kind of get a picture of what this graph is behaving like, and then why that's important to us. Okay, so we'll start with average rate of change. So average rate of change is very similar to the slope formula. The only difference is with average rate of change, you are going to have to find your y values yourself. So it's going to give you an interval of x values, and your job is to create a set of points and then use those points to come up with an average rate of change. But it's essentially, if you remember the slope formula, you'll be okay. It's a very similar formula. Okay. So find the average rate of change of the given functions on this given interval. Let me get my pen. Okay. So if I'm looking at f of x equals x squared plus 1 over x on the interval from 2 to 4. Okay, now this includes 2, it does not include 4, but the nice thing about average rate of change is that we don't care. It doesn't make any difference whether it's included or excluded. It does not change the math that you are going to do. Okay, so we can kind of ignore the fact that it doesn't include 4, and we're going to pretend that I can plug in a 4. So f of 2 is 2 squared plus 1 over 2, which is 4.5. F of 4 is 4 squared plus 1 over 4, which is 16.25. Okay. Once I have those, then I can start to find my average rate of change. So we use delta x over delta y. Delta is a Greek letter, and it's not a triangle, but it looks like a triangle. So if you just draw a triangle, everyone will know what you're talking about. Okay, so delta in math settings means the change in. So I'm looking at how much did y change and how much did x change. So the change in y over the change in, or the change in y over the change in x, which definitely means I wrote that wrong. Delta y over delta x, sorry. So it's going to be f of 4 minus f of 2 over 4 minus 2. So 16.25 minus 4.5 divided by 2. Which is 5.8. 875. Okay, now what this tells us is this is an increasing interval. So over this interval, whatever happens in the center, we're not 100% sure because we're not looking that closely, but that interval gets bigger. That is a positive number, so it has a positive change over that amount of time, and so on that interval, it is increasing. Okay. If I take f of x is 2x cubed plus 3 over x on the interval from -10 to -3, then f of -10 is 2 times -1000 plus 3 over -10. So we've got 2 plus -2000.3. F of -3 will be 2 times -27 plus 3 over -3. Which is a -55. So our average rate of change is going to be -55 minus 2000.3 over -3 minus -10, which is going to be a -293.6. So that's a negative number, which means over this interval, our function is decreasing. It might go up and down a little bit, it might spike a little bit, but overall, I end up lower than where I started. Okay. Average rate of change from a table or a graph is very similar, except that I don't have to plug in the numbers to get my y values. You can just read them off of the graph. And looking at a table, right? Take 2 rows, there's your x value, there's your y value. Taking a graph, read them off of your graph, there's your x value, there's your y value, and then go from there. Okay, so for an example, find the average rate of change on the interval from 0 to 3. So I need to find f of 3, which means I go to 3 on the x-axis, and then I go up until I hit whatever that point is, which happens to be a 7. So f of 3 is 7. Then I find f of 0, so I go to 0 on the x-axis up until I hit my graph. I hit my graph at 1, so f of 0 is 1. So delta y over delta x is going to be 7 minus 1 over 3 minus 0, which is 6 over 3, which is a 2. So we're saying that over that amount of time, if I were to connect those 2 points with a line, that line would have a slope of 2. And because it's positive, we're looking at it's increasing on that interval. Okay. If I look for the average rate of change on the interval from -2 to 2, then I need f of -2 and f of +2. So f of -2 is going to be 7. F of +2 is going to be 3. So +7, +3. So delta y over delta x on that interval is going to be 7 minus 3 over 2 minus -2, which is a 4 over 4. Sorry, -4. I've got that backwards. That should be -2 minus 2, which is a -1. So it's a negative line. It's decreasing. So over that time period, notice it goes down and then it starts to come back up again. doesn't matter. All we know about it, what that rate of change tells us, is that over that amount of time, that graph as a whole decreases. From a table, f of negative 3 is going to be negative 6. F of 9 is going to be positive 2. So my average rate of change is going to be negative 6 minus 2 over negative 3 minus 9, which is a negative 8 over a negative 12, or 2/3. So on that interval, it is increasing. On the interval from negative 9 to 9, so I need f of negative 9. So negative 9 gives me a 10. Sorry, negative 10. F of positive 9 gives us a 2. So our average rate of change is going to be negative 10 minus 2 over negative 9 minus 9. So I get negative 12 over negative 18, which is also 2/3. Okay, they won't always match. Just happened this time. All right. Now, given a polynomial, so if I take a large polynomial, which is something like this, okay, you get those really funny, curvy-looking graphs that do a bunch of wiggling around. When I look at those, we have to kind of decide in intervals what's happening. So identify where it seems to be decreasing and increasing. So before we do that, we actually need to find our maximum and minimum values. And that means find these little places where that graph kind of stops and turns around. Okay, so for your maximums, it's just the places where it's at its highest point. So in this case, I have a maximum, and we're going to call it 3, 1, even though it's not quite at 1. We're going to pretend, and we're just going to round and make it look presentable. Okay. For minimums, there are 2 of them. I have one of them at 1, negative 1, and I have another one at 4, and we'll call that 3/4. So we'll say it's about 0.75. Okay. Now, increasing intervals, the interval only uses the x values where it's getting bigger. So it gets bigger right here, so between 1 and 3, and we never include the endpoints. So this is one of the few times where we always use round parentheses. We never use square bracket. Okay, so always round parenthesis in this scenario. Okay, it's also increasing past 4, right? Gets bigger over there. So we say or 4 to infinity. For decreasing, it starts decreasing, right? All the way from over here, it's decreasing to begin the graph. So negative infinity to 1, and then decreasing from 3 to 4. When you combine your increasing and decreasing values, you should, probably 99% of the time, especially in this class, you should end up with the entire domain. So everything should be included in one or the other. Okay? If it's not, probably just double check before you turn it in. Just double check that you've got all of the increasing and all of the decreasing in there. Okay. All right, so increasing, decreasing. Now, because these little points end, we actually count those as minimums. If they are arrows, they are not. But if they actually have a point, if they come to an actual dot instead of an arrow, then they get to be included in the increasing or decreasing parts. Or I'm sorry, in the maximums or minimums. I still don't include them in the increasing or decreasing parts, but they get to be a maximum or a minimum. So we start with those. So I've got maximums at -216 and at 216. And then I have minimums at negative, we'll call that 2.5 and 12, 0, 0, and a third one at 3, we'll call that a -10. So with my maximums and minimums, then I can talk about increasing. So it is increasing from -2.5 to 2. Then it decreases for a bit. So I'll just write that down. Decreasing from 2 to 0. Sorry, those should be -2's. Okay, from here to here. Then it increases from 0 to 2 and decreases from 2 to 3. Okay, so we've got all of our pieces, everything's identified, we are set. All right, so here is your participation quiz for 3.3. You can go ahead, you can screenshot this if you want to and just write on it, but find me the average rate of change for the equation p of x is 2x squared plus 1 on the interval from -2 to 3.